Hello, welcome to my Multisim video for the digital design project. This is a video where I'll basically be outlining some of the ways basically how I went about designing the circuit I analytically derived uh, in my lab report. And so here it is, actually correctly outputting the digits of my student number, and we'll just wait until it reaches the next iteration. So 4, 0, 0, 4, 3, 4, 7, 3, 8. That's my student number, and we can tell it's correctly being outputted to the 7-segment display. So some of the color coding I used for the circuit. So first of all, I have this Q0 output as in turquoise, and the reason I don't even need a flip-flop for a Q0 is because I found that I could obtain it by taking a NAND between the Q3 and Q2 bits and an AND with the Q1 bit to get that result. So that simplified my design a lot. And for Q1, I used purple, and not Q1 would have been purple as well, but I didn't actually need it. Q2 is in orange, and so is not Q2. Q3 and not Q3 are in blue, and Q4 and not Q4 are in light green. And also, I have Q5, and if I don't actually have not Q5, but both of those would have been labeled in crimson, or whatever this color is. As for some other coloring I used for the clock, I used a yellow wires. Presets and VCCs were both set to red, as well as clears. And for the results of AND gates, I used the color navy. And for the results of NAND gates, I used dark green. And this circuit didn't actually use any other gates other than that. So except for this NOT gate, which is just here to regulate some of the logic in the decoder to ensure that it outputs to the LCD only on a rising edge. So so let's go over some of the logic and how it was designed. So this is the JK flip-flop corresponding to the third bit, and the J input is given by Q4, Q5, and not Q2. Q4, Q5, not Q2. And I basically used two AND gates to build this, one taking Q5 and another taking Q4. And then I ANDed the result of that with not Q2. And this goes into my J3 input. My not K3 input, I found that I just needed to ground it, so that's what I did. And now moving on to the JK flip-flop corresponding to the second bit. So the J input is a not Q4, so I just connected this and I labeled it in green. The not K2 was a result of an AND between Q4 and Q5. So here it is, Q4 ANDed with Q5, and the result of that is entered into the not K input, and this should actually be in navy. I don't know why it changed. So next I have the J1 and not K1 for this flip-flop corresponding to the first bit, or the Q1 bit. And what this logic actually is first of all, an AND between Q4 and Q2 for the J1 bit, and and as you can see, both of those go into this AND gate, and they come out to the J1. And for the not K1 input, this is just Q2, so I just connected it like this. And then for the counter states I have, which are J4 and J5, the input to the fourth JK flip flop, or the JK flip flop 4, it has a J of not Q3 and not K4 of 0, I guess. So I just connected it to ground. And then the J5 has an input of 1, so I connected it to VCC, which is also connected to some of the clears as well, which makes some things convenient. Or actually I'll go over this a bit later. This not K5 is an AND between Q1 and not Q4. So I have Q1 and then I have not Q4 ANDed together, and the result goes in not K5. And this, yeah, that's about it. It's not super complicated. I found a really nice simplification. And yeah, so as for these two, these are just my presets. I use these to set my presets. So what I'll do is, if I run it and then I press my space bar, this will just keep outputting 8 if it's not lagging. And then this will bring me back into this loop of corresponding to my student number 400434738. So I guess last of all, I forgot to talk about, or I did speak about this. Yeah, so just this Q3 bit comes in here. It gets ANDed with the Q2, or NANDed with the Q2 bit, and the result of that gets ANDed with the Q1 bit, and then we get the Q0 bit from here. All of these Q1, Q3, Q2, Q1, Q0 bits get inputted to the decoder. The decoder goes to the LCD, and this is just connected back to ground. Yeah, it just gets connected to the LCD, then the LCD displays what we want. Yeah, so that's about it for my circuit. Thank you for watching my video. I hope you have a good day.